So now that you have seen that relationship, we can look at the parts of the pyramid and the formulas for that. So we could have a square pyramid, that's where the base is a square, or a hexagonal pyramid where the base is a hexagon. Now if I draw from the tip point straight down to meeting a right angle with the base, that distance is called the altitude. The altitude. It's from the top point straight down perpendicular to the base. Now, if I considered this to be a three-dimensional object and I went and sat on the top and I slid down one side so that I landed perpendicular to the base that way, that distance is called the slant height. And you'll see how we'll use the slant height and the altitude at different parts in the formula. The formula for the volume is the area of the base, whatever the base was, use that formula for the area of the base, times the altitude divided by 3, just like you saw in the previous video. So let's look at an example. Here's example 1. The base here is a rectangle. So the formula for the base, the area of the base, is base times height. Or in this case, the area of the base is 5 times 6, which is 30. Now the altitude is this distance that goes straight down perpendicular to the base. So the altitude is 7. And finally, that means that the volume is the altitude. So this is the volume, is the altitude times the area of the base divided by 3, which of course is 70. And the units are cubed. So it was meters in this problem, so the units will be meters cubed. In the next example, I have a cone. And a cone works similarly to what we saw with a pyramid, but here the base is now a circle. So the formula for the base, the area of that, is pi r squared. The radius is 3, and so the area of the base is pi times 3 squared, or 9 pi, or if I use my calculator and multiply that by 3.14, I get 28.27 inches cubed. Oh, not cubed, inches square, because it's area. The altitude is 9 inches. And then the volume, just like we did with a pyramid on example 1, the volume is the altitude times the area of the base divided by 3, which gives me 84.81 inches cubed. Looking now at example 3, kind of takes you a second perhaps to look at what this shape is going to be. We can see this shaded part here is a triangle. That's what's on the bottom. So the base of this is a triangle. Now a triangle's formula is base times height divided by 2. And remember, the base and the height always have to be perpendicular to each other. So that's that 16 and that 5. That's the base and the height. So the area is 16 times 5 divided by 2. You can use your calculator to see that's 40 square feet. The altitude is how tall the whole pyramid is. That's 10 feet. That distance that's perpendicular to the base. And so now my volume is the altitude times the area of the base divided by 3. That's 400 divided by 3, or 133.3 cubic feet. And we've got one more example here, a little bit more difficult. Here's what we've got. We've got a 1, 2, 3, 4, 5, 6. This is going to be a hexagonal pyramid. So the base is a hexagon. Perhaps you remember that the area of a base here is the apothem times the perimeter divided by 2. So the apothem, you can see we've drawn in there, is 7.79. The perimeter is going to be 6 sides that are each 9 feet long. That's 54 feet. So the area of that hexagon, that shaded hexagon, is 7.79, that's the apothem, times the perimeter, which is 54, divided by 2. Grab your calculator, multiply those out. You're probably not going to do that in your head. And that's 210.33 square feet. Oh, and all of that can go down here. Where should I put it? Now the altitude, this distance right here is the altitude. That's 16 feet. So my volume now is the altitude times the area of the base divided by 3. Using my calculator, 1121.76 cubic feet. So those are some ideas on how to find the volume of a variety of pyramids as well as a cone. Let's work on the homework now, and it may help you if you have this formula chart out that shows the area of these different things that could be bases. Use your notebook, use your calculator, use your formula chart, and work on this assignment. Good luck.